Good morning, everyone. Thank you for joining to this webinar. My name is Alay Rodriguez, FA for Ion Associates, and today, along with my colleagues Raul Dominguez and Marvin Govindan, are going to talk about the solution that we can support with the supplier that we represent. If you have any questions during this webinar, you can submit them using the Q&A window in the Zoom application, and we will try to give you the answer at the end of this webinar or during the webinar. Welcome. These are the topics that we will see today regarding EV charging. We will talk about electric vehicles market, standards for EV charging systems, AC stations, DC charging station, wireless and onboard chargers. And also we will continue with talking about the technology that we can support with the supplier that we represent. I give the speech to my colleague Marvin Govindan. Welcome, Marvin.
Hi. So how is the market evolving? So the rise in the use of electric vehicles is simultaneously increasing the need for electric vehicle charging stations. The EV charging station market will register a compound annual growth rate of over 16.3% in the period between 2018 to 2023. One of the major drivers for this market growth is the growth of investments by major players to improve charging infrastructure. Technological advances in EV charging will be key in order to drive growth. APAC leads the market in 2019, and the region is expected to dominate the market through 2023. The European Union currently has more than 400,000 public charging positions and aims to keep growing. The AC segment held the largest market share in 2019. By 2030, more than 70% of the public charging stations will feature fast charging. Next. Let's have a look at how EV charging is today and how it will be in the future. Next. So we have some issues, some problems facing EV charging. There is a capacity gap. There's a lack of public charging stations in general. The charging time should match the time spent per location. Flexibility, you can't plug in wherever you like. So that's not available yet. Information, there's no infrastructure information available, or it's limited. And for added value, proprietary systems without added value for charging, for the charging functionalities. So here we're talking about data transference as well. So, to know how much charge we charge the vehicle and to register that data. So all the systems are proprietary right now. Next.
So another thing to consider, thank you, Marvin, is maybe we need to remember are the standards for EV charging. In this section, we will mention a couple the standards that are governing the EV market, not only for US, but also for Europe and China. We have identified two standards, SAE for the US market. For the US, it talks about methods and levels, and IEC, mainly used for Europe and China, and it talks about modes. For both of them, we will find that there are two charging methods available. One using AC power line levels and another one using DC ray voltages. As we can see in this slide, we can identify 4 different installation types. All represent different charging and power levels. Level 1 charging uses a direct cable connection between the standard single-phase AC wall outlet, also protected by a circuit breaker, and is connected to the vehicle. With this level, AC1, we can achieve a charging power of up to 1.9 kilowatts. With level 2, we can work with single phase or 3-phase AC line. For this, we will use a stationary charging station, also protected by a circuit breaker. And for this, we will also require communication between the vehicle and the charging station to control the charging process. In this level 2, we can achieve output power or charging power up to 20 kilowatts with using around 80 amps of current. With this level 2, SAE level 2, we will find that is comparable with IEC's mode 3. Also, we can see a third one, a DC fast charger, which, as we can see, it provides a DC rate voltage to the vehicle, normally high power, high voltage. This will allow us to maximize the charging process and therefore reducing the charging time for the vehicle. This third mode 3, for example, is also called DC fast charger. Also, we can find a 4-1 wireless charger that is also under development for home and public installations. We will find different difference between AC charging station and DC charging station. One of the main one is that for AC charging station, the charging system is inside the vehicle. This is called onboard charger. Unlike the DC charging stations that in which the charging system or circuitry is inside the kiosk station. If we take a look at the AC charging station in a block diagram format, we can better identify some of the components or the key components that in which, in this case, we can provide support. Since an AC voltage is provided to the vehicle kind of directly, the component count in this part is really low if we compare with a DC charging station. That, as we can see in a block diagram also, it includes more components. And this is mainly because we are transforming AC voltages to DC voltages, including the different stages like PFC, power factor correction, filtering, monitoring circuits, feedback control, and of course, DC to DC converter stage. Next, I will pass to my colleague Raul Dominguez, that we will talk about wireless.
So we see also wireless EV charging. This is a variant of the DC charging. The thing here is that you don't need the connection, the direct connection of the electricity. We have seen that we have wireless charging now in cell phones, and it's the same principle with the cars, with the EV charging, where you have a big antenna, a big coil in the ground, in the floor, and another antenna in your car. So you couple those and you get the juice from the electricity. This has the advantages that you have a reduced setup charging time. You don't need to get out of your car. It's more easy for the customer, but it has its drawbacks. For example, you lose some of the electricity when you are charging that way. It's not much, but still you are losing. If you don't couple all the antennas, you won't see the fast charging. So everything accounts for that. Next, please. Okay. Oh. So here we are seeing a block diagram of the wireless charging station. So again, we start with the AC input because all the electricity we see is distributed in AC. Then we need to go with the protection. We need to rectify and do the power factor correction for the electricity. Then we need to convert it to high frequency because that's the way that it will be sent through the coils. We have the impedance matching network to couple to the coils. And then we're seeing the coils here, for example, in the bottom of this bus. But besides that, we need to control it. And we have two ways of controlling it. It can be wireless or wired. Normally, if you're also using wireless charging stations, you will use wireless communication to control that, because it's kind of nonsense to do the wireless power charging and then have to connect something through wires. Normally, the user interface will be an app on your phone that will ease the payment and also the charging conditions. Now, let's talk about the technology. We talk that we need communication for some kind of chargers to manage the loads, but we're growing more. So we will see when EV charging meets Wi-Fi, because charging ecosystems are developing right now. Is more like the gas stations, where you arrive to the station, to the charging station, you plug, you pay, and that's it. So there's nothing more on there. But Wi-Fi will enable more than just a charger. So we will be able to collect more information, send more information, performance, charging conditions, days, locations, car status, battery status, age, and more. For that, this is a standard that will be released in the next years. It's not in place already, but it will define Wi-Fi as a standard communication for Wi-Fi for EV charging. So if you are planning to do the EV charger or have a electric vehicle and you will have to connect it, it's better to be prepared with the Wi-Fi technology. So here we can see how is the charging ecosystem currently. So today, as I was mentioning, you have your electric vehicle, you have the EV charger, and the communication is just to have the right amount of electricity flowing to do the charging. And that's it. You don't have nothing more. What we will see in the tomorrow days is that besides that, we will have this communication, this Wi-Fi that will be able to operate in cloud systems. So you will be able to collect more data and send more data. For example, one of the problems right now is that sometimes your batteries that are very expensive on electric vehicles stops working. You go to your car vendor and say, hey, this is defective. And they normally say, hey, you charge it incorrectly. Sorry. Now, if we have this more information, more data, we can show the car vendor that our vehicle was charged in the correct ecosystem using the right chargers, the right loads, everything. Or for example, if we are charging in one place and the vehicle identifies something wrong, it can upload to the system, and then we can have more information to compare our previous charging times with this, and then go and sue the current charging station because they did something wrong. So this will be an enabler for new business models, because right now we will not be only talking about batteries, electricity, and charging. There will be data, so there will be opportunities to do newer business with this big data. So this is the standard we were talking about, the ISO 15118. This will work for either EC-DC plug charger or the wireless charger. And what it will do is enable this big amount of data to become available to the ecosystem. So you will communicate to the EV charger pole. Even you will be able, by the standard, to pay using your app. Because right now, some users need to have or pre-buy some cards to use some stations. This is becoming an annoyance to the customers. Sometimes it's a decision maker to decide which kind of car use. For example, in Europe, some users were using with the gas BMWs and Mercedes-Benz, and they opted to go with Tesla because they have a better infrastructure on the charging stations. Now with this standard and everything being compatible, we'll avoid those decisions by charging stations, because you will be able to plug and use and pay in whatever you like. We have several solutions for this Wi-Fi. As you can see, we have automotive, because if you are planning on the auto side, we have modules that comply the automotive standards, and also the industrial. So we can help even in the car side or the charger side. We have different kinds. We have the host base, for example. This one needs a big processor where the stack will be run. And our module is just used as a transceiver with its firmware. But this allows to have big power. For example, if you will be having like a big gateway in your charging station, you will be only needing one of these and be able to handle all the communications. We also have this hybrid architecture, where you also need a host processor, but the stack is in our module. So it's easier to implement, because we already have the stack to be used. The standalone is the easier one, is the more simpler one. Here you will be using the 80 commands to communicate to our module, to our Wi-Fi module. And it's very easy to implement. It's easier to standardize and to certificate. Here are some examples of what we can offer to you. You can see which of those are industrial and automotive. We can offer single bands, dual bands. The newer ones are these Jodis. We will see that here we can find dual bands, big power. We have more to come. We can help you. We also have some simple ones if you decide that you will be designing for a simpler charging kiosk, for example, in some stores where they need just to have one or two poles. We can help you. We have a lower end modules that will enable this communication also. And when you have wireless communication, you need antennas. So with Pulse, we can help you with this. We have several kinds of antennas. We have worked with OEMs, with industrial, with consumer. We can help you. We have different types of antennas. We have embedded ones that are mounted and soldered to the PC boards. We have the discrete components to help you to do the tuning matching. We help you with the matching. We can do it for you if you select a Pulse antenna. We have internal antennas. These are like the flex ones that are glued inside the casing, the plastic casings. We have externals in buildings, vehiculars that withstand everything on the vehicle. We have outdoors. These kind of white antennas are the best ones. For example, Cisco and Sigfox are using some of our antennas in their gateways. And also we have different capabilities, because we can do custom antennas that are adjusted to what you need exactly. Now Marvin will help us to see some key elements of charging kiosks.
Thanks, Raul. So yeah, at a charging kiosk, I mean, we can imagine what things we'll need, as we see here in the pictures. So we need to generate receipts. Maybe there could be digital receipts or paper receipts. We want to know the charging status or payment status. We need lots of confirmations. Confirmation the vehicle's connected, it's charging, so much in the car as in the kiosk. So we need lots of complementary elements. So if we switch to the next slide, please. So what can we add into the kiosk? Well, we have with IEI, we have single board computers, and these things there are lots of different versions of single board computers, but a few of them have been identified exactly for this application, for kiosks. So on the left hand side, we can see a version that has been used. It has First, it was compact and low power, as it says. It has an Atom processor in there. It uses only 6 watts. The whole system for, say, monitoring could be under 35 watts. So we have Windows IoT on there. What other features will we see in the hardware? We'll see, we want to be able to connect multiple monitors. Maybe you know, it's a charging station, but for multiple vehicles. So it could be like almost like a hub. So we might need various independent displays. We may need some kind of connectivity for Wi-Fi, local area networks, even 4G. So we have a SIM card slot there if we need that, and a Wi-Fi module. And we may need to expand the functions, connect other equipment, and it needs to withstand the robust environment. And obviously, as with most single computers, it needs to be fanless. We don't want mechanical parts on this. We have a good heat sinking you know, with a big dissipator on the processor, and maybe an extra chassis around it if we need that. So lots of things are customizable. So you can see here, there's you can do some measurements, some monitoring. You can have a payment system on there and multiple monitors and connectivity. Next. So it's not, we have lots of different versions. So here we have 2 versions. We have the wafer and the nano single board computers. They have different specs, but as we can see, we have high-speed interfaces, triple displays that can be defined. A lot of the times the interfaces can be customized for different resolutions, for different, if it's for VGA or for HDMI. There's lots of things we can do with these things. So we have those, we have more options available. Next slide, please. So also we have a case study. I've put information, summarized information here, but I can send you more. So in a system in Europe, they actually integrated these parts into a kiosk. We have like a simple gateway, which has a dual display, some LAN ports, and we have an industrial computer there, an industrial display. And again, so it's like a touchscreen display. It's robust, and IP65 for, you know, to be good for the environment it's going to be in, which is a cold, humid, wet environment. So depending on the kiosk, on the specifications, we can supply solutions. These are 2 solutions of hundreds of different solutions we can supply. So as it says that the electronics fast charging station must provide the connections and features needed for both the user interface and payment processing, and the back-end connection to the central management system. And a nice summary there. Next. Also with ABB, they've actually advanced in a complete solution. They have the Terra 360. You can see here on the right-hand side in the picture. They have it's a charging station for multiple vehicles, which has been rolled out. But also what goes inside it is what we see on the left-hand side. We have a fast charger rectifier, 3-phase. It can give output voltage between 50 to 1000 volts. It's good for it works in a wide range of temperatures, -20 to 70 degrees C. It can give 30 kilowatts at 55 degrees C. And basically we have more information on this, but it's something which is already available to be integrated. So we have things as well, which if you're looking for a more complete solution, something which is pretty much developed, we have that as well. Next. And now I'll pass over to Raul. Thank you.
Now let's talk about the technology on board the electric vehicles. So we will talk about different topologies there. We will see for example, the first one we see is the battery management system, because these batteries are made by cells. So we have different cells. The normal technology chemistry we are using, the principle is lithium ion, that offers high portability, high energy density, low self-discharge, few memory effects. So it's ideal for this kind of vehicles, but it still has its problems. For example, the two principal are overcharging produces overheating, and overheating can lead to fire or explosion. So we need to take care of that. And also, discharging them below a certain threshold can reduce their capacity permanently. So if you draw all the power, all the juice from the battery, at the end, you will be losing capacity, and we don't want that to happen. For that, we have these battery management systems. Again, we have several daisy chain connections in the cells connected in series. We have a lot of them, and we need to balance them. So to balance them, we need to know them. We need to read the voltage, read the temperature, communicate between all of those connections to a central controller. So we have with Pulse all the magnetics needed for battery management systems, automotive grade. So we have sensors, we have inductors, we have transformers, we have filters that can help into that. So talking more about what battery management system does is taking care of three primary things. The first one is voltage, because we need to keep the voltage uniform along all the battery and balance. So we need to equalize the charge between the cells. It's very important. If not, one cell will degrade faster than the other, and at the end, this will reduce our capacity in our battery. To accomplish this, we have some components like this pulse electronic sensor that can act as a sensor. We can detect a drop or increase in the cell voltage. Again, these are automotive grade. Also temperature. We need to check the temperature, not in the whole battery because we have several cells, but in each cell, because if one cell is overheating, we need to disconnect it or to stop the regenerative charging or do something to avoid the temperature to keep rising. For example, for this, we have this little fuse sensor that we can use for temperature. Another thing that we need to manage is the state of charge. So this is, again, with the balancing, we need to safeguard them from going below the threshold. Again, if we take all the juice out of the cell, it will become damaged permanently. So we need to start doing the Coulomb counting. So we need to determine the amount of electric power that is left in each battery cell and tell it to the control, because if we are seeing that we have 50%, nothing happens. If we are seeing that we are in the lower 10, maybe we need to start sending some alerts. And if we go below 8, stop the discharge, because if we go below 5, it won't work anymore. It will lose a lot of capacity. Also, we need to know when charging, because these fast charging batteries can accept the fast charging to 80% of the total. So you can do fast charge of 80%. You cannot do fast charge of the remaining 20% to have the 100. You cannot. So the charger needs to know where you are in the battery to apply the correct charging, discharging option. So for that, we need the communication also. This component from Pulse is also low emis interface for Ethernet to help us to filter and have a very good communication in there. Now, also on the vehicle side, we have the onboard charger. So we need to, we get from one side the AC voltage, and on the other side, we have the high voltage output directly to the battery. This, we need several steps. This is a block diagram, simple one, but you will need PF chargers because you need to do something with a power factor correction. If not, you will pay a lot and you will be punished by the electricity company. You need to check the current that is being withdrawn to feed the controller. So we have some current sensors. You need to have IGBT drivers because you need to enable, disable in order to do this switching to boost the voltage, the DC voltage. And for that, you will need some drivers. So with pulse, again, we have the drivers. You need to get rid of the EMC in the output. So we have some output EMC chokes. And again, if you are designing something onboard charger, battery management system, or anything in the vehicle side, on the charging side, we can help you. Just give us a call, an email, a message, and we'll help you. The other portion that is explained more in detail here is we need to boost the DC voltage. So again, we need the current sense magnetics. We have the same need of the gate driver transformers. We have the transformers, the DC-DC transformers, and we have also the output inductors. So these are using the high voltage managed in the batteries that is ranging from 200 to 800. And also sometimes you have the battery at 500 volts and you need to go back to the 12 or 24 or 28 volts that are used in the secondary systems. So you need to go from the big voltage to the lower voltage. Again, we have all the magnetics to help you there. And sometimes you will need a high voltage inverter because you will have your energy stored in the car. We remember, I think last year, winter last year, when there was severe weather in the northern Mexican territory, the southern US. In Texas, there was a lot of blackouts, and some people were using their cars. If I recall well, it was a Ford pickup that had this high voltage inverter to power up the essential things. So you will have big batteries in the car, and then you can use this voltage inverter to feed back. So again, we have all the magnetics that you need to include there. And now let's talk about batteries. These are not only in the vehicle side, but can be also in the charging station. I will explain why. But this is normally what we see, right? We have big models, big battery models that are optimized for the bus, but we are not only fitting buses. We can also see these material handling carts. We have smaller mobility. So all of this is vehicle charging. Difference is capacity, but all of them needs a battery. And we have the batteries for those. So we can help you with the design, we can help you with the standards. If you need specific certifications, we can help you with those. TWS is a very big company that are supplying to the most renamed brands in the world. They are focusing currently in mass volumes, but in these electric vehicles, as you see, they have tons and tons of cells. So each battery is worth checking. But I was saying that not only in vehicles we will need batteries. Right now, we are seeing that we have the need of fast charging, but some infrastructure, the electrical wires in the roads are not prepared, or there's not an electrical substation near the charging station in order to provide this fast charging. So right now, some companies are starting to check what is called the ESS, the energy storage system. So they will have huge banks of batteries in order to provide the fast charging, and also those to be charged on the night or avoid the peak hours, so they can draw from the grid more electricity at lower cost. So now if you are planning also a charging station, you can benefit for it because you will have a big banks selling expensive electricity to the cars and buy cheaper electricity from the grid. Marvin?
No, well, let me continue. So thank you for that, Raul. Now, moving forward on the different stages that we can find in these chargers, let's talk about some of the solutions that we can offer on the processing stage, or some of the recommendations that we can offer for the processing, including the DC power stage for the logic components. Gowin is a company that offers a couple of FPGAs with automotive grade classification. Normally, we've seen, if we take a look at how are FPGAs within the vehicle markets, we normally see these products on the clusters, or now replacing analog dashboards to digital dashboard, and with the capability of for controlling all the big displays within the vehicles. But if we remember, FPGAs are can be used since they are low power and they have high power capabilities. We can implement, or we can embed some DSPs or use external DSPs to implement or to control the H-bridge circuitries for the DC voltage generation. So FPGAs can be an option within these stages. Okay. Also, if we remember, not also FPGAs but also DSPs require different rate voltages or sequency for the voltage applied for these devices. In this case, with MaxLinear, we can support with a couple of PMICs, power management ICs, for the sequency process and voltage for these devices. Not only we can support the PMICs, but also we could be able to support some regulators or power modules. So using their portfolio, we can review if there are some products, LDOs, or also DC to DC book converter that can be applied for these applications. Moving forward on the different stage, we also covered before with the support of Raul some of the power components that can be provided to the charger. But let's take a deeper look of some of them. Talking about the power components, we can identify some components with some of the suppliers. We will see MOSFETs, IGBTs, diodes, working with normal or traditional silicon technology, but also for these kind of products, we are also considering silicon carbide or gallium nitride technologies, which can help us to improve the efficiency. As we remember, they have the capability to switch at higher frequency, so we can reduce thermal dependency. We can be able to reduce some other components within the circuit, like inductors, transformer, or even heat sinks. So this will help us to reduce the size of the normal components, or the normal traditional circuits. Also, on power components, we should consider, as we mentioned before with Raul, the magnetics, the transformers, the chokes, the current sense, and relays and contactors should also be considered for reliable high power switching. Complementary solutions for these mentioned components will be also taken into consideration, like the gate drivers or protection devices for our voltage, for our current, like TVS, for example. And let's not forget about the sensors that we talked about for monitoring the battery, but also for all the components within the circuit. We could also consider the temperature or also rate switches. An example, if we go back to the block diagram, an example of the components that we can support in this case with Littelfuse, we can identify some of the parts or part numbers that can be suggested for some of the block diagrams that we can see. For an AC power station or an AC charging station, we can identify protection devices like MOVs, GDTs, PTCs, or protection devices like MOVs or simple ESD protection. If we move forward, if we now take a look at the DC charging station, we will find similar components, also the protection devices, the fuses, but considering that we have also in this circuit more stages like the power factor correction or the DC to DC converter, we can find the silicon carbide diodes. We also have some silicon carbide MOSFETs from Littelfuse that we can support, and also the gate drivers for them. Talking about if we see another part of the block diagram, we will find that some of the components will repeat, but in different stages of the circuit. For wireless charging station, we also find similar components, such as the temperature sensor, silicon carbide MOSFETs, and much more components that we can see on this slide. Moving forward on the technologies and the supplier that we can support for these products, we will see that some designs will prefer or will require to use different technologies. In this case, gallium nitride technology. For this purpose, with GaN systems, we can support GaN FETs. They can help us with 100 volts and 650 volt series FETs with a wide range of MOSFETs starting for 4 amps up to 150 amp range. And also they have they offer some products qualified for automotive grade standards. GaN systems also support the customers with some reference designs and application examples. One of these is an onboard charger with an output power of 7.2 kilowatts with 96% of efficiency. We also have some other examples like a traction inverter, which we have here the link for this example, and also DC to DC converters. So if we take a look at the page or the web page of this supplier, we will see some reference designs and application that can help you during your design. Moving forward on the suppliers that can help on your design for the power stage, we can find that American Settler offers or has different relays that can be applicable for the different charging profile requirements. We can see some series, some part numbers that are recommended for level 2.1 market, level 2, or mode 2 and mode 3 standards. For all of these, we can help you with some samples and some extra recommendations. Also, if we remember, we were talking about not only the relays but contactors for the AC stationary charging stations. In this case, for the contactors, we have a XMCO series that can support up to 90 amperes that can be applicable for level 2 from SAE standard, or for IEC standard, we have it can be applicable for mode 3 charging. Also, Settler has another business unit called Settler Magnetics that can help us as an alternative supplier for the current sense transformers. That can be a reliable current sense solution to measure and to protect the current that is passing through all of our system. Also, with Settler Magnetics, we can support or make some suggestions for AC to DC modules with output power from 1 watt that can go from 1 watt up to 20 watts. These AC to DC power supplies are normally used only for the auxiliary power supply, which means mainly for the logic stage of the system. Also, and finally, on the power stage, we saw different IGBTs, so we will find some IGBTs or MOSFET silicon carbide solutions that need to be controlled from the logic stage. So in this case, with the supplier Skyworks, we can help you with some of the digital isolators or isolated gate drivers. Also, we have the link for this for you to review some of the products. Moving forward, on the communication, we previously talked about the wireless communication solution, but there will be some other solutions that require wired or direct wire connection, like we saw on the charging stations, DC charging station or AC charging station. For this, we can consider some suppliers. In this case, with MaxLinear, we can support products that can have the ability to support the G.hn standard, which is normally used to transmit high-speed data over AC or DC ray voltages, which compare, of course, with previous or other technologies like normal PLC, we can deliver gigabit speeds over these ray voltages. So this can help us to monitoring data or interchange information between the vehicle, the charging station, and not only that, because of the this can help also to reduce the number of cables or wires required to implement some other components within the vehicle, like cameras, sensor devices. So G.hn with MaxLinear can be another solution for wired communication. Now let's talk about about connectors with Raul.
So we will need several kind of connectors, either from one side or the other side, talking in the auto or the charging station. We have several types to offer. We have wire-to-wire, wire-to-board, board-to-boards, high voltage. We have some that are waterproof. So you tell us what you need to connect, and we will give you some of the options. We do this with Amphenol ICC, that is one of the biggest connector companies in the world. So we will handle these slides, and there you will be able to see some automotive solutions in these links. Also some for the EV charging and several examples. So once again, if you need help with a connector or another component, just let us know, and we'll guide you in the process.
Now we'll talk about some thermoclad products. Next, please. So thermoclad, it's a type of printed circuit board, but this board can have an aluminum or copper base. It can be used for heat spreading, so you can mount your electronic circuits on there. And if you're generating high amounts of heat, this technology can help extract that. So usually have maybe the copper foil on top of a dielectric on top of this metal base. So basically, if you need to do some heat spreading, with the design with thermal bias, we can help you with that. Next, please. So, when you're making your circuit, sometimes, if you're going to mount on a metal base, you need to understand track thicknesses, differences between FR4 and using an aluminium base or a copper base, how much copper we're depositing. And we have lots of graphics depending how much current you're pushing through your circuits and what the trace thicknesses should be or shouldn't be, and possibly what the temperature rise will be at those parts. So all of that can be analyzed. Next. Yep, the dielectric we choose, that will help, depending on the application, that will help to understand the withstand voltages, prevent arcing, and short circuits. So depending on that, we choose the dielectric that's required between that metal base and between that copper foil and the thicknesses. Next, please. So yeah, we have two standard base metal types. It could be aluminium or it could be copper. We can find out the characteristics we want of the aluminium. We want to avoid warping as well, and we have different thicknesses. So depending on the design, what the circuit is, where we're using it, we can choose a product that will fit the application. And there are lots of panel sizes available as well, depending on what we're printing in terms of circuit.